Hi everyone. In this video, we are going to learn about LC oscillations. Okay, L here means inductor and C means capacitor. Okay, now LC oscillation doesn't mean oscillations of inductor and capacitor, but it means energy which is stored in capacitor and inductor, it oscillates. Like what happens, you have a capacitor and an inductor. Okay, now initially this capacitor is supposed charged. Okay, and after charging it is connected with this inductor. Okay, so now what happens, this capacitor, once it is connected with the inductor, the circuit gets closed and this capacitor, it starts losing energy, and this energy goes to the inductor. Okay, so the entire energy from the capacitor goes to the inductor. Then again this inductor, it starts losing energy and then it goes to the capacitor. So this oscillation of energy between capacitor and inductor, this is called LC oscillation. Okay, so that is the introduction that is given from NCERT. So this I have taken from the NCERT textbook. We know that a capacitor and inductor can store electrical and magnetic energy. So capacitor basically it can store electrical energy and inductor can store magnetic energy. When a capacitor initially charged, so capacitor is initially charged, is connected to an inductor, the charge on the capacitor and the current in the circuit exhibit the phenomena of electrical oscillations, similar to the oscillations in mechanical systems. Okay, that is we have studied in class 11. Okay, so these oscillations are called as LC oscillations, because they take place between an inductor and a capacitor. So see, suppose we have this capacitor. Now this capacitor is initially charged and then it is connected with an inductor. Okay, so this is positive plate, this is negative plate, this is terminal A, this is terminal B. Okay, acha. Now at t equal to 0, capacitor is having maximum charge, so Q is equal to Qm. And now C is connected, capacitor is connected to the inductor. Now once capacitor is connected to the inductor, what happens? Q starts decreasing. Okay, Q decreases, charge on the capacitor decreases. Okay, and when Q decreases, what happens to the current? Current start increasing, so current increases. Now current increases implies di by dt, it is greater than 0. Di by dt is greater than 0. Okay, acha. Now here see, this charge starts flowing in this direction, so that means current, this is positive plate, so this is the direction of flow of current, so current is flowing like this. Okay, so this terminal A will acquire a high potential and terminal B, it will have a negative potential. Terminal A is connected to positive plate, so terminal A is having a positive potential. Terminal B, this terminal B, and it is connected to this negative plate of the capacitor, so it is having a negative sign, negative potential. Okay, so that means we can say that VA potential, see, A is positive potential, B is negative potential, so VA is greater than VB. Okay, so now let us apply Kirchhoff voltage rule or Kirchhoff voltage law, KVL, Kirchhoff voltage law, to the this loop. Okay, so here see, initially charge is Qm, but after some time, at t is equal to time t, charge is now Q is equal to Q. Initially it was Qm, maximum charge, now it has decreased to Q. Okay, acha. Now see, we'll start from this point, this side, and then we'll go in this direction for this Kirchhoff voltage law. Okay, so this is negative plate. This is negative plate. So we are going from negative side to positive side, that is low potential to high potential, that is gain in potential. Okay, so gain in potential means positive sign. So Q by C plus Q by C. Okay, now then we are moving from A to B, that is high potential, to low potential, that is loss in potential. So that is equal to minus L di by dt. This is the potential drop across the inductor. Okay, now total potential drop, it is equal to 0. That is Kirchhoff voltage law. Okay, acha. Now what is di by dt? See, di by dt is the rate of change in current. Okay, now what is current? Current is dq by dt. Current is dq by dt. Okay, acha. So that means di by dt, it will be equal to d square q by dt square. D square q by dt square. But here, see, we have seen that current increases and charge is decreasing. Q is decreasing. So that means I will be equal to minus dq by dt, and di by dt will be equal to minus d square q by dt square. So if you substitute that value over here, so what do we get? We get q by c plus L d square q by dt square, that is equal to 0. Okay. Now this can be written as d square q by dt square plus q by LC is equal to 0. Okay. Now this is of the form d square x by dt square plus omega naught square x is equal to 0. Okay. In simple harmonic motion, we have seen this equation. So if you compare that, here this LC, it is equal to 1 by LC is equal to omega naught square. Okay, so omega naught, it is equal to 1 by square root of LC. Square root of LC. Okay, so this is the angular frequency of the oscillation. Okay, angular frequency of oscillation. Okay, acha. Now for this, now we can write this equation as, so this term can be replaced, 1 by LC can be replaced by this omega naught square. Okay, so we can write this as d square q by dt square plus omega naught square q, it is equal to 0. Okay, now for this differential equation, we can write the solution as q is equal to q naught cos omega naught t plus phi. This is the general solution. Okay, general solution. Okay, now see, at t is equal to 0, charge is maximum, q is equal to qm. Now here q maximum is q naught. So if you substitute this value over here, so this q naught is equal to q naught cos omega naught into 0, t is 0 plus phi. Okay, so that means cos phi is equal to 1, cos phi equal to 1, or phi is equal to 0. So that means initial phase is 0. Okay, initial phase is 0. So here that means this term is 0. So since this phi is 0, we can write q is equal to q naught cos omega naught t. Okay, acha. Now what is dq by dt? From this, dq by dt will be equal to minus q naught omega naught sin omega t, omega naught t. differentiation of cos is minus sign, so that minus sign is written here. Okay. Acha. Now what is current? I is minus dq by dt. Okay. Why this minus sign? Minus sign is because as charge is decreasing, current is increasing. Okay. So if we take bring this minus sign to the other side, this will become positive. Okay. And this is current. So current is equal to q naught omega naught sine omega naught t. Okay. Now where we can take this expression q naught omega naught as the peak current. Okay. So the expression for current becomes I is equal to I naught sine omega naught t, where I naught it is equal to q naught omega naught. Okay. So this is the value of the instantaneous current, and this is the value of the instantaneous charge. Okay. Acha. Now let us see how the energy expression looks. See, energy in the capacitor, it is in the form of electrostatic potential energy. So electrostatic potential energy of the capacitor, it is equal to q square by twice c. Okay. So now q, substituting the value of q as q naught cos omega naught t square of this divided by twice c. So that is equal to q naught square by twice c cos square omega naught t. Okay. How about the energy of the inductor? UB, energy of the inductor, it is stored in the form of magnetic energy. So it is half Li square, half Li square. So that is equal to L by 2. What is I? I is I naught sine omega t square. I square is I naught sine omega t. Okay. But what is I naught? I naught is q naught omega naught. Okay. So instead of this I naught, I can write q naught omega naught. Okay. So this is equal to q naught square omega naught square L by 2 sine square omega t. Now previously we have seen that omega naught square, it is equal to 1 by LC. Okay. So if we make that replacement over here, so this becomes q naught square by twice c sine square omega t. Okay. So see, from this expression, this is electrostatic potential energy. So what is the maximum value of electrostatic potential energy? Electrostatic potential energy will be maximum when this cos term is 1. So that is equal to q naught square by twice c. Now similarly, what is the value of the maximum energy stored in the inductor? This inner expression will be maximum when this sine term is 1. So this is again q naught square by twice c. Okay. And what happens when you take the sum of the total energy, that is electrostatic potential energy plus magnetic potential energy? If you add these two terms, that is, you have to add this term, and this term. So this sine square omega t cos square omega t becomes 1. So this is equal to q naught square by twice c. Okay. So maximum energy stored in the capacitor, it is equal to maximum energy stored in the inductor, and that is equal to the total energy of the system. That is equal to total energy of the system. Okay. See, we had the capacitor and the inductor. Okay. This is capacitor, this is inductor. Now initially the capacitor is charged. Okay. Now suppose it is having 10 joule of energy. So that means total energy of the system is in the capacitor and it is 10 joule. Okay. Now at this stage, what is the energy of the inductor? It is 0. So what is the total energy? It is 10 joule. Okay. Now when inductor acquires that entire energy, when entire energy from the capacitor goes to the inductor, at that time capacitor will have zero energy, and again the sum will be equal to 10 joule. Okay, now at some intermediate stage when capacitor has suppose 5 joule of energy, so that means the rest energy has gone to the inductor. So energy of the inductor, it will be equal to 5 joule, and that is equal to 10 joule. So that means 10 joule is the maximum energy, 10 joule is the total energy, and it will be equal to the maximum energy of the capacitor or maximum energy of the inductor. Okay, so this is what we have got just now. See, we wrote UE max, it is equal to UB max, and that is equal to U, that is the total energy of the system. Okay, so this is a common, see, this from common sense also we can say, we can understand this. Okay, and that we have mathematically derived it. Okay, this is what we got. So this is what we got, UE max is equal to UB max, and that is equal to sum of the energy of the capacitor and the inductor. Okay, so this is all about LC oscillation.